Okay, so now we've got this cool rule that we can do anytime we have a negative exponent. And it works exactly like the rule did when we didn't have negative exponents. And all we're going to do is whatever that number is in the exponent, we're just going to bring it down and multiply and subtract. So if I have something like y equals 3x to the negative 2, the derivative is negative 6x to the negative 3. Why is it negative 3? It's negative 3 because negative 2 minus 1 is negative 3. This is calculus mistake number 26. Anytime you have a negative exponent and you subtract, you actually have a smaller number than where you started. So don't say negative 2 plus 1. That's a no-no. And we're trying to avoid those at all costs. Okay? So what do we got? We've got negative 6x to the negative 3. Well, check out our problem. Check out our problem. We've got y equals x squared plus 3 over x. They want us to find a linear tangent at the point 1, 2. xy, 1, 2. Okay, so find an equation for this curve. What's it look like? It looks like this. Number 1, this x down here can be rewritten into the numerator with a negative 1. Don't forget that little rule. Any exponent can go from the top of the fraction to the bottom or the bottom of the fraction to the top by making that exponent an opposite of what it currently is. So what problem am I really dealing with here? We're actually going to work on this problem. X squared plus 3 times x to the negative 1. And when I work on it and look at it this way, I have u and I have v. So now I can use the product rule and life gets nice. So what's the product rule look like? Let's just remind ourselves real quick. So I'm just going to come over here and help us remember that if I have u times v, the product is u times v prime plus v times u prime. Okay, those aren't ones, those are primes. So what does this look like for us? Well, it looks like, come on in, woman.
Is Austin here today?
No, he's not here today. So all we need to do then is we just need to look at how we've got u and v set up and then use our product rule. So what's the derivative, what's u going to be? Well, it's just going to be x squared plus 3. What's the derivative of v? Well, the derivative of v is going to be negative x to the negative 2 power. That's it. That's all we got to worry about. And then plus the derivative of u, which is going to be 2x, okay? And then times v. Well, what is v? Just x to the negative 1. So when I simplify this all out, all I have to do then is just go through and multiply things together. And remember, if the bases are the same, in this case they're all x's, I can add the exponents together and that will give me my final answer. So negative x to the negative 2 times x squared. If you multiply those together, that's going to be negative x. And then when you, let me get a black color here. That's going to be negative x. And then negative 2 plus 2 is 0. Okay? Now hang tight. Don't panic yet. Minus 3x to the negative 2 plus, and then over here on this side we're going to have 2 and again times x to the 0 because negative 1 plus 1. What does this mean for us? That means anything to the 0 power becomes the number 1. Anything. So what we're going to end up with is negative 1 minus 3x to the negative 2 plus 2, which will give us for a final answer negative 3x to the negative 2 plus 1. Now, this is a good answer, and this is what our derivative looks like. But sometimes you will run into a teacher or a professor who doesn't like to see a negative exponent in the numerator. And if that's the case, we just really easily move that sucker back down to the denominator. And when you do that, you have the opposite value of your exponent. Okay, so both of these answers right here for me are good answers, but again, pay attention to the instructor that you have and how they exactly want the answer written. All right, so now we've got this derivative. We've got it all cleaned up. We know exactly what it looks like. The question is, how do we find the equation of a linear tangent at the point 1, 2? Well, easy. We have a point 1, 2. We have an x value 1, and our derivative gives us the slope of a tangent line. I mean, it doesn't get any easier than that. So what we're going to do is we're just going to take that 1 that we've got for our x-coordinate, this bad boy right here, and we're going to plug him into our derivative right here. So everywhere we see x, we put in a 1. That's going to give me right here negative y prime equals negative 3 over 1 squared. So here's what it's going to look like, and it's going to give me this guy. And oh, by the way, the derivative is the slope, so I have a slope and a point. What's that give me for my final answer? It gives me y minus 2 equals negative 3 times x minus 1. If you didn't want to write it that way, you could move the 2 over so that you have y equals negative 3 times x minus 1 plus 2. I would stop there. You're not always going to get a really pretty slope like negative 3. Sometimes it's going to be a fraction. And you know what? This is the equation of a line, and that satisfies the question that we were asked. Okay? So that's all there is to it. It's a two-parter. And that's really it. It's kind of a fun, easy, much simpler way now that we can write the equation of a tangent line.